Hello friends, welcome to the online lecture series of Basics of Computer Network. Myself, Assistant Professor Mr. V.R. Wadekar from Matochi College of Engineering and Research Center, Nasik. Guys, we are studying unit number 3, that is multi-access, mechanism and Ethernet standards. Before starting our today's lecture, let's have a quick revision. Guys, in previous lecture, we have studied about a multiple access techniques, that is channelization. In channelization, we studied about FDMA, that is frequency division multiple access, TDMA, that is time division multiple access, and then CDMA, that is code division multiple access. Now guys, in CDMA, we came to know that how it is different from FDMA and TDMA, because in CDMA, one channel it is going to occupy the entire bandwidth link, whereas all the stations in CDMA, they can send the data simultaneously. We also seen the encoding and the decoding of composite signal in CDMA. How to encode it, how to decode it by using your voltage table, how to create that voltage table. And we have seen some examples. So let's start with our today's topics. Today guys, we are going to see what is IEEE, what does it do, what is IEEE Ethernet project 802, and what is standard Ethernet. So let's start what is IEEE. So guys, Institute of Electrical and Electronics Engineering. Basically, IEEE, it is an international non-profit professional organization for the advancement of technology related to electricity. And you know, it is the largest technical professional organization in the world with more than, almost 360,000 members in around 175 countries. And what does this IEEE do? So basically, it is going to produce the 30% of the world's literature in the electrical and the electronics engineering and computer science field. It also sponsors or co-sponsors more than 300 international technical conferences each year. And it publishes an extensive range of peer-reviewed journals, and it major international standards body, nearly 900 active standards with 700 under development. Now, what is this IEEE 802 standards? So basically, in 1985, the Computer Society of the IEEE, they started a project which is called 802 to set standards to enable intercommunication among the equipments from a variety of different manufacturers. And project 802, it is a way of specifying functions of the physical layer and the data link layer of the major LAN protocols. So IEEE 802, it is a family of standards for LANs, that is local area network, which defines an LLC and several MAC sublayers. So IEEE 802, it refers to a family of IEEE standards, and they are dealing with local area network and metropolitan area network. But they are also restricted to networks which carries variable size packets, and they're specified in IEEE 802, which is mapped to the lower two layers, data link layer and physical layer. And the most widely used standards for your LAN connections are there. It is 802.3 Ethernet, 802.4 token bus, and 802.5 token ring. So let's start with our discussion with Ethernet IEEE 802.3. Now, IEEE 802.3, this standard, it specified the CSMA CD as we already studied. That is carrier sense, multiple access with collision detection, media access control methods. And it is the most employed access method for LAN using a bus or tree topology. Almost all LAN technologies are vanished, but Ethernet, except Ethernet, because Ethernet has the capability to update itself according to the need. And it is the media access control method which is used by what? Ethernet. And most widely type used at present with a huge installed base and considerable operational experience. Its protocol is very, very simple. Stations in can be added without making the network down. And the delay at low load is practically zero. That is no token waiting concept it is there. So as we know, Project 802, it doesn't seek to replace any part of OSI model or any TCP IP protocol suite. Instead, it is a way of specifying functions of the physical layer and the data link layer. Now, the relationship of this 802 standard to this TCP IP protocol suite, it is shown in this figure. The IEEE, they have divided this data link layer into two sublayers, that is LLC, logical link control, and second it is your MAC sublayer, that is your media access control. Now guys, as we know that data link control, the data link layer, it handles framing, flow control and error control. So in IEEE project 802, flow control and error control and the some part of framings, these duties are collected to this one layer that is called LLC layer, that is logical link control. And framing is handled in both LLC as well as MAC layer. And this LLC, it provides a single link layer control protocol for all IEEE LAN. It means this LLC can provide the interconnectivity between different LANs. Now, talking about this MAC layer, that is media access control, it defines a specific access method, for each LAN. For example, it defines what? CSMA CD as the media access method for Ethernet LAN. And it defines the token passing method for this token ring as well as token bus LANs. And out of which Ethernet, it is one of the most popular method. Now, the original Ethernet was created in 1976 at Xerox Palo Alto Research Center, that is PARC. Since then, it has gone through 4 generations. So what are those 4 generations? These 4 generations are standard Ethernet, which has a data rate of 10 Mbps. Then comes fast Ethernet, which has a data rate of 100 Mbps. Then gigabit Ethernet, which has a data rate of 1 Gbps. And next it is your fourth is your 10 gigabit Ethernet. That is, it has a rate of what? 10 Gbps. This is frame, it is called a Ethernet frame, or which is also called as 802.3 MAC frame. Now, let's study this each subfield in detail now. First, talking about your preamble. So this field, it contains a 7 bytes. 7 bytes in the sense what? 56 bits of alternating ones and zeros. Why we are going to use this field preamble? In order to alert the receiving system to coming frame and enable it what? Synchronize its clock if it's out of synchronization. And this 56-bit pattern, it going to allows the stations to miss some bits at the beginning of the frame. And the preamble, it is actually added what? At physical layer. And it is not a part of the frame. It is just for alerting your receiving system that next frames are coming and you have to synchronize your clocks. Next, guys, it is your SFD. That is a start frame delimiter. Now this field, which is of 1 byte, which is 10, 10, 10 and 11, it is going to signal the beginning of the frame. It is start frame delimiter. It means it tells that it is the beginning of the frame. And it warns the stations that this is the last chance for synchronization, because you may miss synchronization in preamble, but this is the last warning that you may not miss the synchronization. The last 2 bits, that is of 1, 1, and the alert the receiver that the next field is what? The destination address. This last 2 bits, it is going to tell the receiver system that next field, it is what? Destination address. And this field, it is actually flag that is going to define the start of the frame. Now, the next part is your destination address. This field, it is of 6 bytes, which is nothing but your 48 bits. And it contains the link layer address of the destination station to receive the packet. Now, when the receiver, it sees its own link layer address or a multicast address or broadcast address, then it is going to decapsulate the data from that frame and passes this data to the upper layer protocol. And next it comes your source address. This field, it is also a 6 byte and it contains the link layer address of the sender of the packet. Next it is your type. This field, it is going to define the upper layer protocol whose packet, it is encapsulated in frame. So this protocol can be your internet protocol or OSPF or and so on. Now, this protocol field, in a datagram and the port number in a segment or a user datagram, which is used for what? Multiplexing and demultiplexing purpose. Next, it is called your data and padding. So basically this field, it carries the data which is encapsulated from the upper layer protocol. And it is minimum of your 46 byte and maximum of what? 1500 bytes. Now, what is this padding? So basically padding means, suppose the minimum length of the data required, it is a 46 byte. So if it is less than that of 46 byte, then you need to be padded with extra zeros in order to make it minimum 46 byte. So adding the padding of this extra 0 is nothing but your what? Data padding. And last field, it is your what? CRC field. That is cyclic redundancy code. This field, it contains the error detection information. because if the receiver calculates the CRC and finds that it is not 0, then it is going to discard the frame. Now next, we will talk about the frame length. Now guys, Ethernet, it has imposed the restrictions on both minimum as well as maximum length of a frame. So as we know, the minimum payload length, which is of actually of data, it is of 46 byte, and maximum payload length, nothing but your actual data, it should be of what? 1500 bytes. Now if we will talk about the length of the frame, so as you can see from the figure, the destination address, and remember guys, we are not going to consider preamble and SFD, that is your physical layer header. So we are not going to consider those as a part of the frame. So destination address plus source address, that is 6 byte plus 6 byte, and the length of the PDU, that is of 2 byte, as well as the 4 byte for the CRC, together the minimum frame length, it is 46 plus these fields, that is of 64 bytes, or we can say 512 bits. And the maximum frame length, it is your maximum payload length, that is 1500 bytes plus 6 byte plus this 6 plus 2, this plus 4, that is your 1518 bytes, that is 12,144 bits. So please just remember, because from the exam point of view, it could be very essential. So just remember this minimum and a maximum frame length. Now, talking about the addressing, Ethernet address. Now guys, each station on Ethernet network, such as it could be your printer, workstation, PC, has its own NIC card, that is your network interface card. This NIC, it is going to fit inside the station and provides with this link layer address. And this Ethernet address, it is of 6 byte, that is of 48 bits, or you can count it as a 12 hexadecimal digits. See, this is hexadecimal digits. Remember guys, Ethernet address, we are going to show it in the form of your what? Hexadecimal notation. There are 2 hexadecimal digits for each space. So this is 2, 4, 6, 8, 10 and 12. So total there are 12 hexadecimal digits are there, and we have taken one of the example of it. And remember, each field, it is separated by this colon. So just remember how to represent this physical address, or we call it as your Ethernet address. Now, talking about a unicast and multicast address, how to recognize whether the address is unicast or whether the address is for multicast. Now guys, a source is always a unicast because the frame comes from one station only, but the destination, it could be unicast, it could be multicast, or it could be broadcast. So how to distinguish a unicast address from this multicast address? So if the LSB, that is the least significant bit of the first byte in the destination address, is 0, if it is 0, this LSB of this byte, first byte, then address is unicast, otherwise it is what? Multicast. And remember, in broadcast address, which is a special case of multicast address, all are ones, all bits are what? Ones, or in hexadecimal we can say it FF. So we would see by means of one example, then you would come to know. So just remember the LSB, that least significant bit of the first byte, it is going to define the type of the address. If the bit is 0, it is unicast, otherwise it is what? multicast. And the broadcast destination address, it is a special case of multicast address in which all bits are 1 or it is F. So let's define the type of the following destination address. Suppose these are the 3 examples we have taken. So please guys note it down, this addresses. Now, to find the type of the address, as I already told, we need to look at the second hexadecimal digit, that is the LSB of the first byte. This is your first byte. So total 6 bytes are there. And each byte there are 2 hexadecimal digits. So we are talking about what? LSB of this first byte. It means what? This second hexadecimal digit from your left side. Understood? Now, if it is even, then address is unicast. It means guys this, I am talking about this address. If it is even, the address is what? Unicast. If it is odd, the address is what? Multicast. And if it is all digits are F, that is ones, then address is what? Broadcast. So unicast means what? Sender to only one destination, one-to-one communication. Multicast means what? One to many, or one to, we can say, in a group, few of the members, many members are there. So which is called multicast communication. And broadcast address, it means one to all. Whatever may be the numbers there are at the receiver, how many numbers of receivers are there, that packet, it has been sent to all the stations, the receiving stations. So therefore, this is, we are going to talk about, it is A, and in binary format it is what? 1010. So it is even, so this is your unicast address. Now talking about the second one, second example, this is your 7. Since it is your odd, whose binary is 0111, so this multicast address, it is what? Multicast address. And third, since all the digits are what? Ones or F, so it is what? Broadcast address. Now, we are going to show, now we have seen the Ethernet address, but from this example, we would come to know that how, the address are sent out online. Because writing point of view, we are going to write it in a different way, but how it is going to be transmitted, it is completely different. Because the transmission, or this address is sent left to right, that is byte by byte. Please remember guys, left to right, that is byte by byte. And for each byte, it is sent what? Right to left, bit by bit. Now you would come to know. So first you have to represent this one. So make one table. So first it is your 4747. So just write it. 47, this is your first byte. Second byte, it is your 20. Third byte, it is your 1B. Fourth byte, it is a 2E. Fifth byte, it is a 08. And sixth byte, it is what? Double E. So now you have to make the binary equivalent of this 4. So binary equivalent of 4, it is what? 0100. And what is the binary equivalent of 7? It is a 0111. Similarly, you have to find the binary of each hexadecimal digit. So since it is a 2, so it is a binary equivalent. 0, all zeros are there. Then it is a 1. So it is a binary equivalent of 1. This is your B. Binary equivalent of B, it is a 1011. Similarly, you have to find the binary equivalent of 2, which is 00010. Binary equivalent of E, it is 1110. 08, that is binary equivalent is 4 zeros, and 8 it is 1000. And next it is your EE, so binary equivalent of E, it is a 1110, and similarly it is also 1110. Now how it is going to be transmitted, guys? It is transmitted left to right, byte by byte. It means what? First, which byte would be sent? First, this byte it would be sent, this one. And next, second byte it would be sent. Because the address is sent left to right, byte by byte. And for each byte, it is sent what? Right to left. Since it is your each byte, this is the first byte. So we are going to first send what? 1. Then this one. Then this one. And then the 0. Then we are going to send this 0, 0, 1 and 0. So in this manner, it would be transmitted. For this is going to be transmitted. That is your 0, then this 0, 0, 0 and 0, 1, 00. Similarly, first, this byte it has been transmitted. But from this byte, this first bit it has been sent, that it is your 1, then this one, 0, this one, then it 1s, 000, like this one. Similarly, first we are going to transmit this 0, then this 1, this 1. It means all these 1s, then this 0, this 1, then these 2 zeros. Getting? Similarly, we are going to transmit first this 0, then we are going to transmit this second 0, then this third one, then this 1 it has been transmitted. Then one by one, this 0, they have been transmitted. And similarly, we are going to transmit this right to left, that is each bit being sent. That is first it is 0, then it is your 1, then this one, then this one, and last this 0, and bit by bit, each bit it is transmitted right to left. So hope so guys, you understood that how bit it has been transmitted. So guys, today we have seen what is IEEE, what does IEEE does, and how this IEEE they made a project which is 802 to your LAN technologies. We have seen how IEEE has divided your data link layer into two sublayers, that is LLC and MAC layers. What could be the different projects as like your 802.3, 802.4, 802.5. And from that, today we have seen about what 802.3 project, that is Ethernet, how the evolution of those Ethernet are there. Then we have seen what is the frame structure of or Ethernet frame of your 802.3, which is also called as 802.3 MAC frame. Then we came to about the each field of it. What could be the minimum, maximum length? How the address, how to recognize the address, whether it is a unicast, multicast or broadcast. What is, how the Ethernet address, it has been, transmitted, that we have seen. So here it is an assignment. So please solve the assignment and you need to submit this assignment to my email address. In next module guys, we are going to see about the categories of standard Ethernet. Then we will see its evolution, that is this fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet. This is my email address, so you can, for any questions or feedback, you can post it to my email address. So it's all about, guys, today's lecture. Thank you very much.